Alright. For the whole what? For the whole calculus department or just AP? Oh, AP. It's the only thing we have. But we got some friends from BC in here. Sorry, I meant the BC friends get the paper. Oh yeah, for sure, for sure. I did make some copies for you guys. For my BC friends. Alright. So like I would there you go. There we go. BC friend? I'm glad that you're here. Let's go. Alright. Everybody good? Guys, intermediate value theorem. You know we gotta remember freaking mean value theorem, average value, intermediate value theorem, extreme value theorem. There's so many different things, right? Can you describe in words what intermediate value theorem is? Anybody tell me? Tyler, what we got?
I was going to say between this point and this point.
Between this point and this point.
It has to pass
all the points.
If the function is continuous.
If the function is continuous, very good. So it's saying between this point and this point, like you can't get from there to there unless you cross all the points in between, right? Hi, friends. What's up? What's up? We just started. Wait. Do I want more? I think I do. X, can I give you some Oreos?
Yes.
Let's go. Oreos? Yeah, for sure I am. Are you gonna take a nap or?
Yeah.
Oh, yeah, that's right.
He broke his butt. Yeah,
Ooh, actually? Did you break your tailbone?
No, it's not really bad bruise. Thank you.
Oreos? Yeah? We're coming? Yeah. Okay. So guys, intermediate value theorem, if you want to write it in your own words, you could say, I'll post this, Liesl. Sorry, it took a long time to get started. Yeah. Yeah. As long as it's continuous. You like some Oreos? Okay. Okay. Listen up. It hits every point in between. That's basically what it says. It says, like, you basically have to break the space-time continuum to, like, go past a point and not touch it. You know what I'm saying? Okay. I like to visualize this stuff. So, like, f of 2 equals 10. That's the point 210. F of 4 equals 20. That's the point 420. Hey, 420. Thank you, Chase. They don't know. 420. Good. 420. Okay. The intermediate value theorem, let's see. Does it say f of 3 has to be 15? No, it doesn't say it has to be exactly in between. That's stupid. You guys, this is the extreme value. It basically says the extreme value theorem, you don't use it as much. It basically says as long as it's a continuous function on a closed interval, you have an extreme value somewhere. So extreme value theorem talks about maxes and mins. So this is not that. Okay. The derivative equals 5. I don't even know what that's trying to talk about. Oreos? Yeah. Things are coming. Okay. But definitely, it has at least one solution. It's basically saying somewhere between 10 and 20, it has to equal 13. It has to hit 13. Does that make sense? Oh yeah, for sure. Yours might not be green now.
I'll just cry myself.
Oh, crap. I thought I posted it, bro. I'm sorry. I'm gonna print it right now, kid. Right now. Okay. There we go for number 2. Hey, do you guys remember the limits chapter when life was easy and we were just doing limits? That was so long ago. It hasn't been that easy since August. Okay, check it out. The limit exists, but it's not continuous. Okay, so first of all, let's look at the place that's not continuous. Like right there, right? Right there, and right there. Those are not continuous. Okay?
Wait, but on number one, how did you cross off D? Because the slope of the line is 5. So does it not have to?
The derivative has to equal the
No. Yeah, but then wouldn't it have to hit 5 at some point along the chain?
Oh, okay. Actually, Tyler, awesome. Hold on. It's true, but not by the intermediate value. It's true by something else. Yeah, that is garbage. So that is a true statement, okay? But that's not what the intermediate value theorem says. Make sense? Okay, cool. But yes, that is a true statement. I think that's what the, oh, you guys, that's mean value theorem, right? Derivative equals slope? That's mean value theorem. Okay. Anyway, so let's go back to here. These are all the points that it's not continuous, right? Okay, does the limit exist right here?
No.
No. Because remember, I'm over here and I'm going that way and I'm trying to meet my friend that's over here and they're going that way. Are we going to meet up?
No.
We surely are not. Is it continuous? Sorry, does the limit exist right there?
Yes.
Not on this one, no. But right here, the limit exists, right?
Yeah.
What is the limit? Right here, out of curiosity. 2. That's right. 1.5 is the point, but the limit is 2. Okay? Very good. So the limit exists at b equals 0. The limit exists at 0. So it's not continuous, but it still has a limit right there. Okay? Yeah?
Wait, but where does it tell you where b goes to?
It just says b is just an x value because it says the limit as x approaches b exists and it's not continuous. What could it be? Yeah, so we wrote it all. Does that make sense? Okay, so basically, like if I'm translating this statement right here, if I'm saying like, if I'm saying what x value does the limit exist, but f is not continuous? That's basically what that says in like non-calculus words, right? Where does the limit exist, but it's not continuous? Well, so what I was saying was let's look at the places that are not continuous, which is there, there, and there. And the only one where the limit exists is right here because they like touch up.
So the answer would be is b equals 2.
Yeah, no, because it says, what x value, so then you got to do 0, right? So it didn't say, like, what is the limit? It just said, this could be a 2, okay? X value of 0. Oh my goodness, you guys, these 1, 2, 3s, you guys hate these? These are all over these.
Yes.
So we're going to look at each one thing at a time. F is a function differentiable on open interval. By the way, if it's differentiable, it means it has to be continuous. Okay? It can be continuous and not differentiable, but differentiable means continuous, so you can't go like the other one. All right, so we have these points. F of 2 is -5, F of 5 is 5, F of 9 is -5. Which of the following must be true? Okay, F has at least 2 zeros. Let's think about this. I'm just going to picture this in my head. Here's 2. Here's 5, here's 9, right? Okay, F of 2 is -5, which is like down here somewhere, right? F of 5 is 5, and F of 9 is -5. Okay? Okay. If it's continuous, is it going to have at least 2 zeros? Do you guys see why? Yeah. And what theorem tells you that? The one we just talked about, yeah. IVT, intermediate value theorem. Okay, beautiful. Does it have at least one horizontal tangent? Okay, let's think about this. So Tyler, this is the one that you were just recognizing, right? If I can make, mean value theorem. The derivative has to equal the slope between the endpoints, right? In order to have one horizontal tangent, what's the derivative at that point? derivative would have to be 0. Given these points, is there somewhere that I can make the slope 0?
Yes.
Yeah, between, because it says -5, right? So the slope on the interval, 2 to 9 or whatever, is 0, which means somewhere the derivative has to equal 0. That's true. That's MVT. That's mean value theorem, okay? That's true. All right, and then let's look at this last one. For some number C between 2 and 5, it has to equal 3. Okay, so look at this. Between 2 and 5, it has to equal 3. I feel like that's true also by I and T, right? Because if I'm going from -5 to 5, then it has to hit every number in between. So this is 1, 2, and 3. Let's go. Okay? MVT, IVT, we got that. Calculator question. Do you guys have calculators? Do you need calculators? There are calculators. Swing around the room a little bit if you need. Feel free to pass back. There might be some on desks or something. Pass back. Okay? Everybody else need calculators? Okay. All right. I'll be honest with you, this one got me for a little second. It did. I was like, okay. But here we go. This is the graph of f, right? Now, the limit as x approaches 1 of the sine of f of x. So I was thinking, like, what the heck is this talking about? All right, that sign is confusing me, right? But let's just take this and go, okay, what's the limit as x approaches 1 of f of x? So as I approach 1, okay, as I approach 1, shoot, okay, I'm getting closer to 1, I think, and closer to 1. What is the limit? 2, very good. So it's not that, right? That's the point at 1, but we're approaching 1. As we're approaching 1, it's 2. So now, I'm like, what is this asking me? I guess for sine of 2, right? Okay, plug that in on your calculator. I mean, there's decimals, so I feel like that's a pretty good indicator that this is going to be a weird decimally thing. Did you guys get 0.909? Yeah. We'll make sure that your calculators are all on radians before you start the AP test. Yeah, we got to make sure everybody's on radians. We'll do that. At our Sunday night fireside, right, Tyler? We're going to have a little fireside.
I'm giving the spiritual thought. Don't worry.
Thank you, spiritual thought. Is someone bringing a tablecloth? Okay. Because then I think we'll be okay. All right. Because it's a fireside, right? Okay. We did that. Okay, beautiful. Here we go. If the limit as x approaches 3 equals 7, which of the following must be true? Now, when it tells you like which of these must be true, what you kind of want to do is look for a counterexample, like something that would make it not be true, because then that would help me, right? So, okay, so as I'm approaching 3, and then this is like 7 up here or whatever, could the limit exist and it not be continuous?
Yes.
For sure, because it could go like that, right? So that's not true. Okay, could the limit exist and it not be differentiable?
Yeah.
Yeah, I think so, because what if it's like an absolute value graph or something with like a hole right there or whatever, right? That's not differentiable. Does f of 3 have to equal 7?
Yes.
Nah, what if my point is up there? Right? Remember, this means point. So the point, it could be like f of 3 equals 9. So guess what? None of the following are true. So mean when it's none, you know? It's like, jeez. Okay? All right, piecewise functions. Okay, cool. This is the function given by, all right. So I want to basically know if it's continuous or differentiable, okay? In order to be continuous, how would I check that?
You have to find out if at 3 is.
At 3, does the left side and the right side meet up, okay? So on my top equation at 3, that's going to equal 3 squared, which is 9. On the bottom equation at 3, that's going to equal 18 minus 9, which is 9. So it is definitely continuous, okay? Now, how do I tell if it's differentiable?
Can you take a derivative of both?
The same thing with the derivative. That's exactly right. Yep, the same, and check it at 3. Because, like, here's the thing, right? If it was continuous, but like, okay, that's an example of something that's continuous and not differentiable. Well, like the derivative right here is not going to match the derivative right there, okay? But if I'm just doing a normal thing where it's continuous and differentiable, that derivative and that derivative will be the same as we come to that point. Does that make sense? So we do the exact same thing, but with differentiable instead of continuous. So it's like, okay, the derivative of x squared is 2x. The derivative of 6x minus 9 is 6. This is where x is less than 3, x is greater than or equal to 3. As I plug that in, I get 6. As I plug that in, I get 6. So it is differentiable. We love that. Both continuous and differentiable.
What would make it not differentiable?
Let's say that this number was like 4x minus 9, and I took the derivative, and then that one would be like 4. That would not be differentiable. Does that make sense? So if the derivatives don't, if these didn't equal each other, it wouldn't be differentiable, but it could still be continuous, okay? No calculators allowed for this question. All right, don't yell at me, jeez. Okay, that just tells you do stuff. All right.
And as long as it's used as decimal.
Yeah. Okay, here's the thing. Standard on the AP test is 3 decimal places, okay? Is anybody taking physics right now, AP physics? Is it 4 in AP physics? Do you know? Okay, but it like tells you? Okay. Yeah, I think I remembered like for physics it was 4, for calculus 3. I was always like, what am I doing? All right. But calculus, you always want to go to 3 decimal places after the decimal point. All right? Blah, 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 blah. Okay, here's my question. Functions, f, g, h, are twice differentiable functions with blah, blah. The line is tangent to both the graph of g at 2 and the graph of h at 2. Find h prime of 2. Whoa, this is a thinker. This is a thinker. Okay. What does, actually not, we're okay. This is the equation of a tangent line. Now, normally, it says the word equation of tangent line, and then I have to write it, right? But this one gave it to me. This looks slightly different than what we usually write, though, huh?
Oh, yeah.
Yeah, like usually we write this. Okay, if that was the equation of the tangent line, yeah, I just moved the 4 to the other side. And let's talk about what's happening at h, okay? What this is saying is when x is 2, right? When x is 2, h of x, h of 2 is 4.
And G.
Yep. And then what's this right here? How do I get that number?
That's the slope.
Oh, so you would maybe say h prime of 2 is how I got that number. Make sense?
Wait.
So this is making me think backwards. Man, when I think backwards, it's so tricky, okay? Because equations of tangent lines, remember how we go x minus x1, that's the x value, so the x value is 2. Y minus y1, so at h of 2, it's at 4. And how did we always get that number?
By putting it into the derivative.
We did a derivative, and we put it into the derivative. So it's like h prime is 2/3, right? So my very first question says, what's h prime of 2? I'm like, ooh, I'm chilling. I can see that right there. That's 2/3. That one was a little bit tricky, right? I mean, and the same is going to be true for g. If it's a tangent to that one as well, the same will be true. I don't know that we need to know that, but just to be concise here. At g of x, okay, because it says that's a tangent line. X is 2. G of 2 is 4, which it like told me up there anyways. And then what's g prime of 2? Also 2/3, because it's tangent lines to both of them. Okay? We like it? I like it. All right. Let a be given by a function 3x to the third h of x. write an expression for a prime, find a prime of 2. This is so fun. Check it out. If I have to take the derivative of this, what rule do I have to use?
Product rule.
Let's go, product rule. Right? So, yeah, right? So, except for look at the next question. Okay. Okay, so product rule, like 3x to the third is a function, h of x is a function. Like, I don't know what function it is, but it's a function. So let's try to write this out, okay? A prime of x. All right, derivative of the first. 9x squared times the second, okay? Oh, wait, don't put 2 in yet. It just wants an equation. Derivative of the first times the second, and then the first times derivative of the second. How do I write the derivative of the second? Let's go. All right, this is great. So that's an expression for a prime. So now find a prime of 2. So now I'm just going to plug in 2. This one, I can actually plug it in and get a value. This one says h of 2, but I feel like I did that a little bit earlier. Oh, crap. Hold on. Hey, buddy. Can you walk home from school today? I don't really know. Can you call your brother or your dad, please? Okay. I'll be there. Yeah, for sure. But can you call your brother or your dad, please? Thanks, bye. I forgot to get my kid a ride home from school. Oops. You know why? It's not that far, you guys. It's like maybe a mile. And yeah, it's uphill, but like, come on. Don't be a freaking whiner. Oh, I'm doing calculus right now. Okay. So what was h of 2? So if I'm coming back up here, right? H of 2 is 4. I'm the worst. It's fine. I'd like care about you guys more, you know? Go walk. Don't care. And then h prime of 2 is 2/3. Ooh, I love this. This is going to come out nicely. 9 times 4 times 4. It yelled at me that I couldn't use a calculator, huh? 36 times 4, 144, I think. Oh, let's go. 144. And then, I mean, at least this one's not that bad because boom, boom. Yeah. Plus 16. Okay, so 144 plus 16. So it's going to be like 160? Yeah. Yes. Okay, I like that one. You guys like that one? All right. That was cool. Yeah, I liked it. Do I have the answers? Oh, yeah, good job. Okay. Blah, blah, blah. Okay. El hospital. Okay. The function h. Oh, now you're going to give me the equation. Okay. X cannot be 2. All right. Fine. The limit as x approaches 2 can be evaluated using L'Hospital's rule. Do we remember L'Hospital's rule? Okay. Okay. There was a condition, yes, it's where you want to go to the hospital because calculus hurts your brain, that said if this equals what, are we even allowed to use L'Hospital's rule?
What L'Hospital's rule?
Okay, L'Hospital's rule is actually L'Hopital's rule, and what it says is that if you get an indeterminate form when you're trying to do a limit, and we'll talk about what that is in just a second. If you get an indeterminate form, you're allowed to take the derivative of the top, the derivative of the bottom, and plug it in again.
Oh, right.
Okay, but in order to use it, like 90% of the time, you're using it when you get 0 over 0.
Right.
Okay?
Okay.
So let's look at the top real quick. What would x have to be to make that 0? 2, which kind of makes sense because that's like right there, right? Okay, look at the bottom real quick. Ooh, this is super important, right? When is the bottom going to be 0? When f of x is 1. You see that? That's tricky because they didn't tell us that. So f of x when f of x equals 1. And the x that I'm plugging in is like 2, right? So when f of 2 equals 1, I can use L'Hopital, which can bring that as L-Hop. That's his rapper name. Okay? Now, hold on. Okay? It can be evaluated with L'Hopital's rule, blah, blah, blah.
It says
Oh,
that it
hey,
can be.
I already got, yeah, but I already got one of my answers.
That means f of 2 has to
It said find f of 2. Boom. Now it says find f prime of 2. Okay. So I got to take the limit of the top and the bottom separate. Don't get like freaked out. I know this is stuff we don't always look at, but just like try to, I don't know. Big deep breath. Okay. What's the derivative of the top? 2x. Easy money. Okay. 2x. Okay. What's the derivative of the bottom? That goes away. Right? So everyone is 0.
3 times f of x squared times f prime of x.
Let's go. So it's negative 3 f of x squared times f prime of x. Okay? Now, okay, hang on. It can be evaluated, but does it tell me what it evaluates to? No. Okay, fine. All right, well, whatever. I'm just going to kind of go with it. Okay, x is 2. So this is going to be 2 times 2 on the top, so that'll be 4, right? Negative 3 times f of 2 squared, and then f prime of 2.
Wait, why is it negative?
Oh, it was negative from back here because that had a negative in front.
Oh, okay.
Right? Then we did a little chain rule. Okay, we already figured out f of 2, right? F of 2 was 1. Can I just like not write this again? Okay, boom. Okay, so 4 over negative 3 times f prime of 2. And can be evaluated. Shows our work leads to your answer. So f prime of 2 just would have to be anything except for 0, right? It can't equal 0. Okay, I got to read this again. It is known that the limit can be evaluated, and f prime of 2 shows our work leads to your answer. All right, I don't feel like you can go any more than that. Hold on. The second point is earned by setting that. Yep. The third point is earned for evidence of applying L'Hopital's rule. Blah, blah, blah. Blah, blah, blah. Wait, hold on. Okay. Yep, we did that. Differentiable continuous. So f of 2 is 1. Boom. Because f is twice differentiable, it exists. Blah, blah, blah. Okay. What am I missing? Oh, this is the same problem.
But it doesn't tell us anything else.
Tell
us anything about f.
It does. Okay, check it out. This is the same problem. Ugh. Okay. It tells me that L'Hopital's rule can be evaluated, which means that, like, if there's, like, a hole, it will fill in that hole, right? Yeah. It means, like, if there's a hole, right, if we can evaluate the limit will fill in that hole, okay? It's basically a way to evaluate limits that are undefined. So let's say I get a limit and it's 0 over 0. That's a hole in the graph. L'Hopital's rule, you can manipulate it to then define that point. We could also do it by factoring, but like this bad boy can't be factored, right?
Yeah.
So, okay. So look, h of 2 is 4. This is the limit as I'm approaching 2. So what this is saying is as I'm approaching 2, it goes to 4. So L'Hopital's rule also needs to go to 4 to fill it in.
Oh.
Ooh, yeah, but this is h.
It says the limit of h, but it puts f of x. So that means f prime of.
So what does that have to equal to give me 4?
It has to be 4 over 1.
So the bottom has to be 1. The bottom would have to be 1. So f prime of 2 would have to be negative 1/3. Woo, baby! Oh my gosh. Okay, hold on. Yo. No, because, okay, it is equal to h, because, look. Let me give you a picture.
Yeah, that was kind of disgusting.
That was bad. I liked it.
You would.
Thank you. Okay, that is when I take the limit as x approaches, let's say that's like a 5, right? F of x, or whatever, okay? And remember, you would get like 0 over 0. But then we'd factor and we'd cross it out and we'd do all this fancy stuff. And then we'd actually get a number right there, right? You guys remember that? And that number fills in that hole, which tells me that I filled it in as f of 5 equals 3. So it was the actual graph that I filled in. Yeah, that was tricky. Now, before you start crying, everybody, what's up, homie?
Can I come help you on Friday with it?
Yeah.
Okay.
Sorry, lunch? A4 or what?
I'm here all day Friday.
All right, I'll text you. You gonna go make a little swim run first, or what? Okay. Yeah, yeah. On a Friday? Yeah.
On a Friday, we'll
Thank you, homie.
Like a double swig?
Yeah, for sure. Extra caffeine. Okay. So, you guys, this is 4 parts. This tells me how it would score that. So before you start crying, right? You already got a point for part 1. You already got a point for part 2. Okay? It's not like every single question has to be 100%. You know what I'm saying? Okay, let's see this now. Let's see this. G is less than H between 1 and 3. K is between G and H. Is K continuous at 2? Oh my gosh, what the heck? Okay, hold on. Bro, if G is some function, okay, here's H, G, so way back up here, if G of 2 and H of 2 are both 4, so this would be like, if that's G of 2 would have to be less than or equal to K of 2 would have to be less than or equal to H of 2, and that would have to be less than or equal to 4, which would have to be less than or equal to 4. So it has to be 4. Was that not? Okay. Here's the thing, you guys, and like, I don't like how this paper has all this, please respond on paper. It's like a little bit stressful. Ooh, my battery's dying. Okay. It's like a little bit crazy, but so we should really like be doing this on another sheet of paper. But what you're going to do when you get your free response question, right? When you get your free response question, in the very beginning of the problem, where it gives you the important information, you're going to like circle the crap out of that or something. You know what I mean? Because it's going to come back through all the parts, you know? You're going to be like, don't forget that. And then when you're on part D and you're like, what is actually happening here? I don't get it. You're going to look back to the beginning and go, okay, from here, it's asking me at x equals 2. So let's go ahead and put in x equals 2. G of 2 is less than or equal to K of 2 is less than or equal to H of 2. And G of 2 is 4. H of 2 is 4. So K of 2 has to be right in between there. Yeah. If I'm not mistaken, I think that's something called the Squeeze Theorem. I don't know. Yeah, because it's like squeezes it. If this one's going to 4 and this is going to 4, it squeezes it. Anyway, so if that's true, then K of 2 equals 4. Therefore, K is continuous. And then you get a point for that one. Because there's a value there. There's actually a point value. Oh, it is the Squeeze Theorem. Oh, I remembered that. Look at me. Okay, let's check it out. I kind of feel like the Squeeze Theorem is only a BC thing, so I kind of feel like my BC kids are worrying about this. And the rest of you guys can breathe for a sec. Guys, BC kids, Squeeze Theorem. Okay. Oh, here we go. Because the limit as it approaches 2 goes to 4, and the limit of that one goes to 4, and the points go to 4, it's like if the limits go to 4 and the points go to 4 and everything goes to 4, then it's continuous. So that was only part of it. That was the points. We also had to do the limits. If that limit went to 4 and that limit went to 4, because, okay, G and H are differentiable, therefore they're continuous. So if they're continuous, the limit and the point have to equal each other, and then that's the Squeeze Theorem. You guys haven't heard of the Squeeze Theorem? Specifically, we know that because it told me that they're differentiable. If they're differentiable, they're continuous, and continuous means no holes, right? So the limit and the point have to meet up, or it would not be continuous, okay? Yeah, because they got to meet up. So the limit of the point would have to be the same. Check it out. Squeeze Theorem. AP Calculus.
I'm still confused why not, because it could just mean that K of 2 has a point at that point.
Right, but we had to do the limits as well. So the squeeze theorem says if it's between x and an open interval as the limit approaches L, if f of x approaches and h of x approaches, then the middle one approaches. It squeezes it up, man. So you got to do the points and the limits. Points and the limits, right? Squeeze theorem. Yeah, for sure. We haven't taught that. That's funny. Hey, that's why we're reviewing. That's why we're reviewing. All right, now we're going to give fun. Unless others specified, blah, blah, blah. Okay, that's all just regular directions. Here we go. Here we go. You guys, so important. Because half the time they're going to give you a graph of f prime. More than half, I feel like. This is actually a graph of f. So that's interesting. Okay. The continuous function is defined, on the closed interval -6 to 5. The figure above shows part of the graph. Oh, they're not showing me the whole thing. 2 line segments and a quarter circle. That's fun. All right, quarter circle. Okay, blah, 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 blah. It is known that the point 3 minus square root 5 is on the graph. Fabulous. Okay. That is the point 3, 3 minus root 5. I don't know. Do we need it? I have no clue. I'm just writing down what they're telling me to write down, you know? What's that? We're going to need it. But it's like, do you know what I'm saying? When you guys read this, so as I'm reading through this, the first thing I see is -6 to 5. And it says it shows a portion of it, and I'm like, oh, there's some missing crap over there. So they're going to make me do something with, like, this part that's missing, I bet. Okay? And then 2 line segments, they're telling me that that's straight because it looks straight, and they're telling me that's a quarter circle. You know what that makes me think? I bet we're going to have to find an area or something. I don't know, probably. Right? And then it's known that that's on the graph. That's a point right there. Maybe they're going to make me find a tangent line. I don't know. Okay? So I don't really know yet, but I'm just writing my info down. Oh, I think that this didn't print. That's supposed to say f of x dx, right? F of x dx? Okay. Does it say that on your papers, hopefully? Or is it a little box? Damn it. Okay. They're like, guess what the letter is. Okay. Okay, if. Now check this out, guys. The integral from -6 to 5. That tells me if I go from -6 all the way to 5, that integral is going to be 7. All right? Because they're jerks, Tyler. So, what is the value of -6 to 2? How am I going to find that? Don't cry. Look, if the entire thing is 7.
Oh, the entire
And then if I could find this, I could subtract it, and it would tell me what that is. Right? I mean, come on. Right? So, as I was thinking, oh, it's going to make me do the area, I'm right. It is going to make me do the area. Okay. Tyler, without crying, you ready? Tyler's having a breakdown, y'all. Be happy that you're here for it. Oh, good. Okay. Wait, stupid funny or stupid stupid?
like. Hey, you have to get free.
I am coloring, my friends. All right.
Wait, so we're going for -2?
Okay. So it told me, right? It told me that the entire thing from 6 to 5 was 7. Cool, cool. We want to know what this is. Huh? Well, we might as well find that part, and then we can see something plus what makes 7, right? Okay? Can we do this one little bitty at a time? I mean, I feel like those cancel out. Let me just make sure. 1, 1, 1, 1. Okay, those definitely cancel out. So that's going to be like 0 together. That's fine. Don't think the same thing about that and that, is because I don't know that that's necessarily true. Because it's over 1, up 2, over 1. Okay, those do cancel out. Good. Okay, fair. I still don't want to do that, though, because then I have to do a trapezoid. I don't know. Do you want to do a trapezoid? Okay. So cancel, 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 cancel. But now right here, I'm going to have to do a trapezoid because I canceled part of it. But that's okay. Trapezoids are 1/2 that and the average of the heights, which are 1 and 3. So my trapezoid is 2. Okay? Now, if I hadn't canceled those little things out, I could do a triangle, but I'd have to do a triangle and a mini triangle and work it out, right? You guys okay with that? If I'm doing something that you're not understanding, you're going to tell me, right? Right, Isaac? You're not going to wait for your brother to explain it to you or whatever? Okay. Gosh dang it, Isaac. Unacceptable. All right. Now, how am I going to find, this is big brain moment, my friends. How am I going to find that little shady part?
You do the whole box and then you do
Box. Box minus 1/4 of a circle. Wait. Yeah? And will that give me the leftovers? Great, let's go. The box looks like a 3 by 3. So the box is 9. Okay, the quarter circle, it's 1/4 pi r squared because it's a quarter.
We know it's 3, R is 3. Right?
Yes, r is 3 because that's the center of the circle.
We know it's a quarter.
Yes, because we know it's a quarter circle, so that's the center. So the radius is 3. Pi r squared. Okay. So that is 9 minus 9 over 4 pi. Okay? That's like kind of ugly, right? Okay. So the integral, because it's pi r squared, but it's a quarter circle, right? So pi r squared, but a quarter of it. So that's where the 1/4 came from. And I know the radius is 3. Okay? Okay. So guys, here to here, can I just say that's 11 minus 9/4 pi? Yeah, because 9 and 2. Okay, so that's 11 minus 9/4 pi. So what's the value of this? 7 minus that. 7 minus 11 minus 9 over 4 pi. Are you going to try to simplify that? No, this is free response. You do not have to simplify that. You're chilling right there. You know? Don't, I mean, if you start simplifying, it's like possible that you could make a little mistake. So I'm going to leave it just like that. Okay? Let's see. What else we got here? Okay. All right, perfect. Because this is 9 and minus 9 pi over 4, and remember my little trapezoid was 2? Okay? So, I mean, you could write negative 4 plus, but, like, I ain't trying to be crazy. All right. How we feeling? Okay. Ooh. Okay. Bless you. All right. If I have an integral, I can split it up, right? I can split it up. Can I also bring that 2 out front? So is this the same thing as saying 2 integral from 3 to 5 f prime of x dx, and then the integral from 3 to 5 of 4 dx. Is that not the exact same thing? Yeah? Cool. Okay. What's the integral of f prime? Yeah, you're right. The integral of f prime is f. So I'm going to do 2 f of x evaluated 5 to 3. Right? And then, what's the integral of 4? Let's go. Doop, doop. Be very careful about that, because if you have a 4 right here, a lot of people, like, the mistake that they'll make is they'll take the integral and then they'll just go, oh, I just have to add 4 to my integral, right? But you got to integrate the 4 also, so that's going to be 4x right there. Okay? Okay. 2 times f of 5. Where am I going to find f of 5? Oh, let's look at the graph. What's f of 5? Oh, let's go. All right, that's easy money. 0 minus, and then I got to find f of 3. Ah, that's why it told us that, right? 3 minus root 5. Now, let's not be crazy, because we're minusing it, and we got a minus, and I'm going to use my parentheses and just try to be okay, right? Because it's minus 3 minus root 5, all right? And then, that's cool. And then on this side, it's 20 minus 12, all right? And like, technically, I can leave it like that. Okay? Yeah, really. On a free response, you can leave it like that, yeah. For sure. It's just like, boom. Yep, that's exactly right. I mean, if you wanted to, okay, so this is like 0 minus, so that could be like 6 minus 2 rad 5 plus 8, so it's like 14 minus 2 rad 5. So on a multiple choice, like I'd want you to go to that step, right? Oh, I didn't distribute my negative like I just yelled at you guys about. How dare I? 2. So it's like negative 3 plus rad 5. So it's negative 6 plus 2 rad 5 plus 8. So it's 2, not 8. 2 plus 2 rad 5. See, that's why I don't like to simplify, because I mess up. All right, that was a cool one. Okay. Now we get crazy, guys. Now we get crazy. Ooh, we gotta make that tiny. Okay.
Haven't we even talked about maximum value in AB?
Yes, but not in relation to integrals yet. But we definitely talked about absolute max. Okay, check it out. Absolute max of a g on the interval.
Oh yeah, that might be that thing. Oh yeah, that's what it's like.
This is super important. Absolute maxes and mins occur at endpoints. That says end doints. Hold on. No, we're chilling. Points or critical points. Okay? Absolute maxes and mins can only occur at endpoints or critical points. I got you, fam. All right, do you guys understand what that means? The word absolute tells me it has to either be at the endpoint of a closed interval, all right, or on the critical points. Now, we have this new function. Gosh, I hate it when they give us new functions. Okay? All right, peace out, Jared. Bye, Jared.
Jared, I like your backpack.
No worries, kid.
I like you, Jared.
I like you too, Jared.
So cute.
Okay. Oh, endpoints, you guys. Look, endpoints. Aha. Endpoints. So my endpoints, and like sometimes just to organize myself, I'll make a little chart. Those are endpoints. Okay. How do I find critical points? What is the definition? Go back to your definitions. Okay. So how do we, like when we were doing all those like increasing, decreasing, max, min, how do we find the critical points? First derivative. First derivative what? Equals 0. Beautiful. Let's go. My friends, can we take the derivative of g? Oh, it's the thing, right? It's the thing with the boom, boom, boom. Let's go. So, g prime is regular f of x, actually. Yeah, it changes to x. G prime is f of x. And I want to set the derivative equal to 0. So the derivative will be equal to 0 when f is equal to 0. Ah. Now, how do we know when f is equal to 0? Well, we go over here. And where is it equal to 0? Oh, 5?
-1.
-1 and...
0.5.
Is it exactly? Yes, because it's a slope of 1/2. Okay. 5, -1, and 0.5. Okay, 5 was already an endpoint by Tyler. Go sing beautifully. Okay. No, it was at... Guys, jeez. Oh, the 5 was already there, so -1 and 0.5. Okay.
Oh.
Okay? You guys, this is so important. This almost always shows up. Okay. I'm so glad we're going over this. Now, these are values. Okay, so instead of making an XY table, like you can, but I'm going to remind myself that this is G of X. Okay? Because remember when we would find the absolute maxes or mins, we would plug it into the original function. You guys remember that? To get the Y values, we have to plug into the original. Now, my friends, look. That is the original function. The original function is an integral. What the heck, dude? The original function is an integral, but don't stress. We got this. Okay, I'm going to do G of -2. Check it out. It's the integral of -2 to -2 of f of t dt, which is, we have a property that tells us if it goes from the same thing to the same thing, it's 0. Cool, cool. All right, next. G of -1 is the integral from -2 to -1 of f of t dt. What does that mean in, like, English and not calculus words? You don't know what integral from -2 to -1 of f of t dt means? That's what's up, Gunnar. The area of the curve between -2 and -1, right? Okay, the area of the curve between -2 and -1. What's the area of that? Yeah, 1/2. 1/2 base times height, right? So integral just means area, and it told me to go from -2 to 1. So the integral of that was 1/2. Okay? Okay, cool. So that's my y value. All right? No, it was above the x's, I think. Yeah, it was above the x's. Okay, now I'm going to do G of 0.5. Looks so stressful. It's not. It's literally what we've been doing. You're good. Okay, -2 to 0.5 f of t dt. In real words, what does that mean? The area under the curve from -2 to 0.5. You guys got it. Let's go. Okay. Oof, I wrote all over this.
Which is 0.
Okay. That and that cancel out. But I have this.
Oh, right. It's just that. I was thinking that it went to 1.
So yeah, cancel out. So it's 1/2 base times height. So is it 1/4?
Yeah.
And it's negative? Okay. Cool, cool, cool. So that's -1/4.
Wait, how come it's negative? I mean,
Under the axis. Yeah, yeah.
does that mean that? Oh, never mind.
Okay.
And then we found out what -2 to 5.
We did that in the other part, didn't we? So G of 5 was the integral from -2 to 5, which we already did. I mean, we can count it up again. 11 minus, wait, what's it? Oh, yeah, 11 minus 9/4 pi. 11 minus 9 pi over 4. Is this a no calculator question? I'll be so annoyed if it is. Does it say?
Yeah.
Ha! That sucks. Okay. So, it's all right. It's all right. Almost. What were we trying to find? Whenever you answer a question, guys, whether you're on an ACT test or an AP test or whatever, you read it before you answer it. Absolute max. That means look over here. Which of those is biggest? Of the y values? Is 11 minus 9 pi over 4 bigger than 1/2?
Yes. Yes.
Do you think?
Yes.
Yes?
Let's estimate. 9 times 3 is 27. Divided by 4 is like...
It's still bigger. It's still bigger.
11 minus 7, it's still bigger. Okay. So if it's no calculator, that's why I was like, you kidding me? This is no calculator. If it's no calculator, it'll be something that you can like reason out. So that is my absolute max. So we would say, how do we answer this? The absolute max of G is 11 minus 9 pi over 4, and it occurs at 5. So they would probably ask you, what is the absolute max, and not necessarily where it occurs. What if it had asked me for the absolute min of G? What would it be?
It would be -2.
Negative. Yeah, at negative 0.5, and then would be -1. That is a very, you guys, if you can master that, that is a very standard AP question, right? We see that kind of thing all the time, where it's the integral of a graph and you got to plug things in. We'll practice, dude. We're chilling. We'll practice. Was that the end? No way. That was the end? Oh, thank goodness. Who was cheering? Are you freaking kidding me right now? All right. It's not even 1 o'clock. All right. Oh, this is so cool. So cool. We got this. Okay. Guys, one step at a time. Big, deep breath. I'm going to write it down here. 10 to the x minus 3f prime of x over f of x minus the inverse tan of x. This is so dope. All right. The first thing we do with limits is we always just try to plug it in. Okay? Let's like hope that this plugs in and we don't have to take another derivative. But let's see. Okay. 10 to the 1. That's cool, right? 10 to the 1. Minus 3 f prime of 1. I'm going to come back to that in a minute. And then f of 1 minus arctan of 1. Whew, there's so many things right there. Like, I feel pretty comfortable with 10 to the 1. Everything else, I'm like, what is going on, right? Okay. So, what does f prime of 1 mean? The slope of f at 1. Okay? Now, this is f we're talking about, not g. F. Ooh, graph of f. The slope of f at 1. What's the slope of that bad boy? Rise over run 2. Okay, cool. That wasn't that hard. What are you guys complaining about? Okay, what does f of 1 mean? The actual point on the graph. That's right. The actual f of 1. F of 1 is 1. Love it. Okay, now this is the fun part, right?
No, it's not.
Arc tan of 1 equals. Woo! Okay, remember it goes like this. The arctan of something, you guys, is an angle, okay? It's the angle, and so what it means is the tangent of what angle is 1. Did we make our best friend chart? Hopefully we made it at the beginning of the AP test, no?
Yeah, but we can't use that while using the AP test.
No, but you're going to memorize it, and you're going to write this down the second they hand you your test. Boop, 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 boop. Or at least by the first trig problem they give you, you're going to write this down, okay? And then you go 1 over 2, right, 2 over 2, 3 over 2, 3 over 2, 2 over 2, 1 over 2, 1 over root 3, 1 root 3. Okay, so this, the inverse tangent of 1 is asking me at what angle does tangent equal 1?
Pi 4.
Pi 4.
Let's go. So the arctangent of 1 is pi 4.
That's what they did.
Hmm?
Okay, cool.
Absolutely.
So, it's
So this
4
is,
over 1 minus pi 4.
that's right.
Well, isn't 5 pi 4 also?
Okay, yes, except I would have to go back and teach you a lot of stuff about inverses. So let's just say always go with the first quadrant, okay? Technically, the inverse tangent is only defined in quadrants 1 and 4. It's not defined in quadrants 2 and 3. There's a big old reason why. I could tell you. It would take me like an hour to explain it. Or you could just know it. You know what I'm saying? You stay here and I will understand it to you. I will explain it to you. Hey, not an English teacher. Math. Inverse sine is only defined in 1 and 4. Inverse cosine is only defined in
3 and 2.
1 and 2. Okay? So that's like so random, but just go with the first quadrant one, all right? And so that is my final answer, 4 over 1 minus pi over 4. How do we feel, my friends? We got this? We got this. Let's go. Okay, JC, if we do 12 more of these, how do you feel? Ready to go, right? Ready to go. All right. Yeah, there's 12 weeks before the AP test, friends. We got this. Go. Wednesday. If anyone wants the next one, grab it right now. Hey, 12 Wednesdays to the AP test, friends. We got this. Yeah, you can give it to me. Thank you. All right, thanks for coming, bro. With your pillow. I love it.